longer distance. So whenever I am saying AM waveform, it can travel for a longer distance, and pictorially we can say like this. So this is the Earth surface. This is the Earth surface given by this kind of thing. So first I am showing the amplitude modulation. This is called as ionosphere. This is called as the ionosphere. If there is a AM transmitter, here this should be exactly parallel. So here there is a AM receiver. So AM modulated waveform, it takes the help of ionosphere for bending. So what happens is this signal is transmitted first, AM signal. So this is AM signal, gets reflected here. Again it goes up, it gets reflected by ionosphere. Again it goes up, reflected by ionosphere, goes up, and then comes here. So this is the path for AM propagation in case of amplitude modulation. Okay. So after many hops, it comes back from the transmitter to the receiver, and distance is quite long. So this is long travel. In case of AM, this is AM signal travel. And obviously this position and this position, they are far away. Far away means 100, 200, 300 kilometers away. Okay. So this is for AM signal travel. Whereas in case of FM signal travel, we call it LOS, that is line of sight communication. And this is the Earth surface. If this is a transmitting antenna like this, and it is received by a receiver antenna. So like this. So this is transmitting antenna, and this is the receiving antenna, and this is Earth surface. So this is for FM, and this is line of sight. So there is a basic difference between AM and FM transmission. So here we can find in case of AM, signal travels for longer distance, 200, 300, 400 kilometers or more. In case of FM, the communication occurs only in case of line of sight. So this is called sky wave propagation. This is called sky wave propagation, and this is called line of sight propagation. So here it is said that it can travel for very long distance. It can have wide coverage area. Whereas in case of FM, it is ground wave propagation. So this is sky wave. This is called ground wave propagation. Okay, it's a ground wave propagation, and it is called line of sight or area of sight communication, like this. Let us now see some of the advantages and disadvantages of both. So it's a comparison kind of a thing. More than the mathematical treatment at this stage, first year, you should know what is AM, what is FM, and what are the advantage and disadvantage of AM and advantage or disadvantage of FM. First I'm trying the AM, amplitude modulated waveform. What are the advantages? What are the disadvantages? So whenever I'm saying it is amplitude modulated waveform, first advantage is it is very simple. The circuits are very simple. The design of the circuits are very simple, very primitive, basic modulator and demodulator model are used in case of AM. So I am doing advantage of amplitude modulated waveform. First is very simple, and whenever circuits are simple, the system costs are cheap. Whenever the system costs are cheap, in that case more number of people can have access to this AM transmitter, receiver or AM system. So that is the first and very basic advantage of amplitude modulated waveform and amplitude modulated system. That same system is simple, system is cheap, and many people can afford it. Second, it can have a wider coverage area, very wide coverage area is having by AM modulator, demodulator. It can transmit for a longer distance, and it can cover huge amount of area, more amount of people can access it. Third is the transmission range, very important thing. Transmission range is 500 kilohertz to 1600 kilohertz. So this is the transmission frequency range for amplitude modulated waveform. So this figure you have to remember, that is 540 kilohertz to 1600 kilohertz. But I'm finding that this is a very narrow band of frequency. Though it looks very wide, so it comes around 1000 kilohertz or something, that means 1 megahertz. All the channels are kept within this 1 megahertz kind of a range. That means that is starting from 500 kilohertz up to 1600 kilohertz. So almost the bandwidth of AM within which the transmission is occurring, it is almost around 1 megahertz, or to be very precise, it is actually 1.06 megahertz, 1.06 megahertz, like this. Okay, so this is more than advantage. This is a figure that you have to remember. So it's a very narrow bandwidth. All channels are very close to each other. That means whatever filter you have to design at the receiver side, all the filters will be having very close pass band. One very important thing, it requires small bandwidth to transmit the signal compared to FM. So FM is having a wider bandwidth, we will be finding, but amplitude modulated waveform is having a very smaller bandwidth. So how much is the bandwidth? It is around 1.06 megahertz. So these were the advantage of AM. Main advantages, it is very simple, it is primitive, the system cost is less, many people can afford it, and it can travel for a longer distance, it can have a wide coverage area. Disadvantage of amplitude modulated waveform. Disadvantage. So there are mainly 3 disadvantages as is listed here. As information is contained in a carrier which is amplitude modulated, in that case it is very easy to tamper the signal, because we are finding that the carrier amplitude is changing with respect to the modulating signal amplitude. That means if we add a little noise with the modulating signal, that will change the total characteristic of the modulated waveform. So first disadvantage and main disadvantage is, as the signal is carried in form of amplitude of the carrier signal, little bit addition of noise and little bit change in the modulating signal will affect the modulated waveform very severely. So exact word is, as information is contained in amplitude of the carrier, it is easy to tamper the modulated amplitude of baseband signal. So whenever the modulated amplitude is getting changed during transmission, whenever the tampered amplitude is received at the receiver side, whatever demodulated waveform we find out, that will be different compared to the actual modulating signal. So the security issue is a big issue in case of amplitude modulation. So little bit of change in modulating signal totally changes the characteristics of demodulated waveform. There is a very big disadvantage. Second disadvantage is, as is discussed, that the bandwidth is very narrow. So within 1 megahertz bandwidth, all the channels have to be accommodated. So what we find is, this is the total channel for amplitude modulation. Each channel is divided, each channel is a part of it. So what we find is, AM channels actually, what we find is AM channels, so these are the figures you should remember, is having bandwidth of only 10 kilohertz. So within this 1.06 megahertz, lot of channels are accommodated, and whenever lot of channels are accommodated, each channel is having very less bandwidth, that is 10 kilohertz. And such many channels together, they are forming this 1.06 overall amplitude modulated bandwidth. So this is the thing to understand. This is the overall bandwidth and this is the single channel bandwidth for AM modulation. So second disadvantage is, the overall bandwidth is very narrow, it's 10 kilohertz. Channels might overlap with each other. So whenever 2 channels are there side by side, at that time they are 10 kilohertz or something, there is a big possibility that the channels might get overlapping with each other, their baseband signal will be overlapping with each other, and there will be distortion at the receiver side. Last thing, transmission power is very high. So in case of amplitude modulated waveform, to transmit the signal from the transmitter to receiver, we need huge amount of transmission power. Okay, so transmitted signal is carrying huge amount of power, so that is, power efficiency is less in case of amplitude modulated waveform. So these are 3 main disadvantages of amplitude modulated waveform. Let us see what are the advantages and disadvantages of frequency modulated waveform. So I'll just list it down. For FM, what are the advantages? So many advantages. So this FM came later on. First came AM, it was in use for quite a year, and later on the FM radio came into picture. First thing, the first disadvantage of AM was amplitude is stored in form of, modulating signal information was stored in form of amplitude. But in case of FM, we are finding that the modulating amplitude is stored in form of frequency deviation. Hence, the chance of signal tampering is less. That means in this case we can say higher security. So this is the first advantage of, and very big advantage of, frequency modulated waveform. That security of modulation, proper reproduction of signal at the demodulator side is higher in case of frequency modulation, because the modulating amplitude is stored in form of not amplitude but in form of frequency, and it is difficult to deviate the frequency, and the amplitude deviation is easier for modulated wave. Frequency deviation is not that easy. So that is the first and very important advantage of FM waveform. Second, ability or adjustment of noise reduction is better in FM. So the ability of noise suppression is better in FM. Okay, so here is a comparison between AM and FM side by side. If you just check, so in case of AM, I said that it is affected by noise to the greater extent. FM, the ability of noise suppression is in our hand, and we can design the system where we can reduce the effect of noise in case of FM. Point number 3, AM operates in MF and HF. So that is one thing. It is operating in mid frequency or high frequency given by MF or HF. But FM it acts in ultra high frequency and very high frequency. So the frequency range of FM operation is much higher than AM operation. So this works in MF, that is mid frequency and high frequency. This works in very high frequency or ultra high frequency. In that case, the frequency range is higher, and in this case the noise effect is less. So working in very high and ultra high frequency, the effect of noise is less. So this third point is actually in the line of second point, that is ability of noise suppression is more, and as the FM is working already in the range of ultra high frequency and very high frequency, we will find that this thing is less affected by environmental noise. So one very important difference between AM and FM, in one line if you say, AM is prone to environmental noise more, whereas FM is less prone to environmental noise. So this comparison may be asked in the exam, so please prepare. It can be prepared from this advantage and disadvantage table. Fourth point, FM has better sound quality. So output sound quality better in FM than AM. So obviously the FM produces a better sound quality than amplitude modulation. Point number 5, FM is having bandwidth. So I'll remove this points here. The amplitude modulation is done. Okay. So here I'll say the advantage of FM. Point number 5, it is saying that the frequency modulated waveform is having a much higher bandwidth or higher range of